Assalamualaikum and hi, what's up guys? So let's continue our lecture on water purification in natural system. So this lecture note is a sequence from the previous lecture note that covers on physical and chemical processes of water purification in natural system. So this will be your part 2 of chapter 1 in our syllabus. You may refer chapter 3 for this part in your textbook. For this lecture note, I'm going to cover on biochemical processes on water purification in natural system. Previously, we have covered these first two parts, which are the physical and chemical processes. Except pathogens, organic matter in water is generally not harmful, but it may be considered as pollutant since bacteria decomposition generates oxygen depletion. In other words, the higher the amount of bacteria or organic matter, so the higher the oxygen depletion. Okay, so meaning that when you measure the oxygen, the dissolved oxygen in the water, it will decrease with higher concentration of organic pollutant. So the amount of organic matter is directly related to oxygen depletion. With regard to this, okay, so there are four main topics in this subchapter that we want to discuss under the biochemical processes of water purification in natural system, which are the first one, metabolic processes, microorganisms in natural water system, and the third one you will see the dissolved oxygen balance, and finally the dissolved oxygen model. Here in the dissolved oxygen model you will see oxygen set curve. Okay, so these four are related to each other. Okay, so before we proceed with metabolic processes, we have to know what is metabolism. So metabolism is the sum total of the process by which living organisms assimilate and use food for subsistence growth and reproduction. Okay, so there are two types of process that involve in metabolism. The first one is anabolism. Okay, anabolism provides the material necessary for cell growth. The second one is catabolism, which provides energy for the synthesis of a new cell, okay, as well as the maintenance of other cell functions. And then there's another reaction that we call as a backup, which is endogenous catabolism. This is used when the external food source is interrupted. So the organism will use stored food for maintenance energy in process. Dissolved oxygen is one of the most important thing in water system. Okay, so microorganism will do the metabolic process that convert the organic along with the dissolved oxygen into new cell and oxidized waste product. Okay, so before we go to the dissolved oxygen, we have to know what kind of microorganisms that exist in the water. So basically the most common significance in microorganisms exist in the water are bacteria, protozoa, and algae. So the first one, we will go to the first one, which is bacteria. Okay, bacteria is classified into three types of bacteria. Okay, the first one is autotroph, which this kind of organism or bacteria derive energy and material from inorganic source, while the second type of bacteria is heterotroph, that obtain both energy and material from organic source. And the final one would be phototroph, the bacteria that use sunlight for energy source and inorganic substance for a material source. Okay, so among these three types of bacteria, heterotrophic bacteria would be the most important one in the degradation of organic material. So we'll see a lot on this one. So under heterotrophic bacteria, there will be two types of this heterotrophic bacteria, which is aerobic and anaerobic heterotroph bacteria. So as it names, aerobic requires oxygen in their metabolic process, while anaerobic utilize organics in the absence of oxygen. Okay. The second type of microorganism is protozoa. Okay, they ingest solid organic for food. And the third important microorganism is algae. So algae is autotrophic and photosynthetic organism. So algae is the only microorganism that involved in photosynthesis. Okay, so in the presence of sunlight, algae will metabolize the waste product of heterotrophic bacteria, the first type of microorganism just now, while obtaining energy from sunlight. Okay, and then this will produce the product of the waste is actually oxygen. If the sunlight is unavailable, so the algae will catabolize and deplete the dissolved oxygen to the point where this can kill the fish or any other aquatic life. So in other words, if you see there's a heavy growth of algae, so it's an indicator that the dissolved oxygen has depleted. Okay, as mentioned in previous slide, okay, dissolved oxygen is one of the most important constituent in natural water system. So we need at least 2 to 5 milligram of dissolved oxygen to maintain the aquatic life. Okay, so in water, there are two mechanisms that can bring the oxygen to the surface water. Okay, the first source is from re-aeration, while the second source is from the photosynthesis of the algae. Okay, so insufficient of oxygen will lead to anaerobic system, which normally produce displeasing colors, taste, odors in water. Okay, that's why some water or some river or some ponds have weird odor, right? Okay, so from equation 3.5 in your book, we can know how much is the dissolved oxygen deficit by the equation, by using this equation. So D is DO deficit, CS is equilibrium concentration, and C is the oxygen concentration. So when the oxygen is used up, thus the deficit D will increase. Meaning that the greater the D, the greater the re-aeration due to the dissolved oxygen has decreased. The final subtopic under this chapter is dissolved oxygen model. Okay, so we will cover on the rate of oxygen removal, rate of oxygen addition, and finally we'll see what is oxygen sag curve. Okay. For the dissolved oxygen model, we will discuss three types of different models to predict changes in the dissolved oxygen in the water. Right. The first one is the model to describe for rate of oxygen removal, and then the second one is to describe rate of oxygen addition, and the final one we will discuss on the equation or model that to describe the oxygen sag curve, where we will use the Streeter and Phelps model for the description of oxygen depletion in the oxygen set curve, right? Okay, now we go for the first model, which is the rate of oxygen removal. So we use equation RD equals to K1LT, where RD is actually the change in the oxygen deficit, okay, due to the utilization of the oxygen. So we can see actually D is a subscript for the oxygen deficit. Okay, so K1 is actually the reaction rate constant that from the previous chapter, in chapter 2, it is actually equation from Van Hoff-Arrhenius equation. So with the theta value is equals to 1.047. Okay, and then so the next model is the rate of oxygen addition, okay, which is our rate of capital R equals to minus K to D, okay, where R, capital R, is a rate at which oxygen becomes dissolved from atmosphere, meaning the addition of the oxygen from the atmosphere. So D is actually the oxygen deficit. So it came from the equation, the previous equation, D equals to Cs minus C. Okay. K2 is actually the reaction rate constant. This is affected by stream, turbulence, surface area, water depth, and temperature. So for the correction, temperature correction, or for K2, you can obtain from table 3.2 with we can use the correlation for K2 is actually equals to K20, K at 20 degrees C, theta T minus 20. So T is the temperature that you want to calculate. Okay, the third model that we want to use to describe the oxygen depletion is by using Streeter and Phelps equation, where this one will be used in the oxygen set curve. Okay, so from this equation you can see that dT is actually oxygen deficit in river at any time t, whereas L0 is actually initial ultimate BOD x mixed stream. DO is the initial deficit at mixed stream. Okay, and then it's either given T, you can find your X or U, or given several distance and velocity, you can determine the T, right? Okay, oxygen set curve is used to describe the oxygen utilization and reaeration in the water. If you look at the figure, it's actually like a graph. Okay, so you will have y-axis as dissolved oxygen, and time versus time as the x-axis. Okay, so oxygen demand causes an oxygen deficit. So the greater the oxygen deficit, the greater the rate of natural oxygen will be replenished from the atmosphere into the stream. So there are two concurrent processes, which are oxygen consumption and also oxygen replenishment, that consequently will produce this oxygen set curve. Okay, I will continue to explain on the oxygen set curve in the next part of the video, because it's already almost 15 minutes of this video. So I have another 5 slides to cover on the oxygen set curve. Okay, see you in the next part. Thank you.